So first of all, let's start with coding for task 1. Okay, so the program begins by declaring 3 constant integers to represent the LED pins. Pin 11 for green, pin 12 for yellow, and pin 13 for red. An integer variable named LED state is initialized to low, meaning that LED start in the off state. And another variable is previous minis is set to 0 to keep track of the last time the LEDs change. And a constant called interval is set to 1000 to represent 1 second in milliseconds. Alright, so in the setup function, the 3 LED pins are configured as outputs so the Arduino can control them, and serial communication is started at about rate of 9600. And inside the loop function, the program actually first stores the current time from millis into the variable current millis. Then it will check whether 1 second has passed by comparing current millis with the previous millis. If at least 1 second has passed, previous millis is updated to the current time, and the program toggles the LED state variable between low and high. And finally, the new value of LED state is written to all 3 LED pins using digital write. This causes the LEDs to all turn on together when LED state is high for 1 second, and all turn off together when LED state is low. As the loop repeats, the LEDs continue blinking on and off every 1 second.
This is the hardware connection. Okay, after that, instead of using the delay function, we are using timer operation, as you can see here. And then when we upload the program, this is the output. The LED will start blinking, high for 1 second and low for 1 second.
So first of all, I declare my coding, which is D11, D12 and D30 is connected to the pin 11, 12 and 13, and then IR sensor is connected to the pin called sensor, and it is connected to the pin 2. I also assigned previous millis 11 and 30 to store the last time each LED is a blink, and then the interval is set to the 1000, which means 1 second. Finally, I use started 11 and started 13 to keep track of whether each LED is currently on or off. Now, in the setup function, I use pin mode to set the 3 LEDs as an output and the sensor as an input. This tells the Arduino which pin will send the signal and which pin will receive the input. Inside the loop function, I first read the current time using millis and store it in the current millis. This is like reading a stopwatch that has been running since the Arduino was powered on. Next, the control LED on a pin D11. I check the current millis and previous millis is greater than or equal to the 1000 millis. If it is greater than 1000 millisecond, that means 1 second has passed. And then I update the previous millis as 11 with the current time, and then use if-else statement and change the LED state. If state 11 is low, I set it to high to turn on the LED. Else, if it was high, I set it back to low to turn off the LED. Finally, I write the new state of the LED pin, which is digital, right? So LED D13 works in the same way as the LED D11, but it has its own timer variable and its own state variable. Again, the problem checks if 1 second has passed. If yes, it toggles the state D30 from low to high or high to low. Then it writes the state to the LED pin. And last, for the loop function, LED 30 with IR sensor. The last part is LED D12, which is controlled by the IR sensor. I use an if-else statement here, and then if the IR sensor is read high, then the LED D12 is turned on. Else, if the sensor reads low, then the LED on D12 is turned off. This makes the LED directly follow the sensor input in real time. In conclusions, D11 and D30 blink every 1 second using timers, and they are independently of each other. D12 turn on and off based on the IR sensor using an if-else statement. And because of I use millis as a timer instead of delay, the LED and sensor can all work together without blocking each other.
This is our task 2, LED with IR sensor. Like before, we are using 3 LED, and this time we are adding 1 IR sensor connected to port 2. As you can see here, we are using timer operation and also if-else function to make the IR sensor work like we want. So this is the output, hardware output. The both green and red LED will always blinking with timer, while this yellow LED will turn on when there is no obstacle on the sensor. If there is obstacle, the LED will turn off, but it will not interrupt the program of these 2 LED.